This Cloudera is starting. Once this is started, then we'll start going through script again. Okay, let's wait till the time. We are doing first one time load today, okay? And we were in between a script of scope. Job wise, we know. Schedule wise, we also know. CD user lib, sorry, user tmp, and this is the file otl.sh, because we need to run this to a script only for any job and data extraction. This is script and this is script. This is one-time activity and this is a daily activity. Now we'll open ETL job custdim underscore otl.sh. Okay, and in Hive we have loaded the data in Hive. So this is line number set in U. This is line number 57. In line number 57, we are running Hive script to get the data from user Hive warehouse. From user Hive warehouse, get the data as in data is already stored in user Hive warehouse. We're just pointing to that location of HDFS, right? Pointing means if my data is present in this directory, user Hive warehouse, then I'm pointing here and creating one table, and that table name I have already given in one option, which is Hive table option. Right? So in Hive table here, we have given already what is the table name which I will create, dim customer underscore OTL. This is the table name in Hive. It will be created inside a default database or inside my FIU database. So default database will be created. Default this table will create inside default database. ETL data schema. So ETL data schema is, I think, FIU. Okay, we'll see when we run this whether it is going to default or FIU. Then once this script is done, this script is taking data from HDFS to Hive, pointing to Hive. Once this is done, it is printing us total time taken by this script, whether the script is success or fail. We need to check this script now. What this script is doing, Hive script underscore OTL, right? So in Hive script underscore OTL, this is the script for Hive underscore OTL. And how do I know this is the script for Hive underscore OTL? Because I will open this parameter.txt file and this will tell me. Can you check this? Hive script OTL. ETL data, ETL cust, demo, TL load, and this is HQL file. HQL file is a Hive query language file, and whenever we want to create any script in Hive, that's HQL extension. Just like in cell scripting, we have .sh, we have Hive, and for Hive we have HQL. So it's a standard extension. We'll open this ETL thing, ETL data, OTL one-time load, and we'll read this set number. In line number 13, we'll start. Okay. So line number 13 says dynamic partition true. What was dynamic partition in Hive? If we want to get few columns from one table and want to write in other column, then we use dynamic partition, and partition helps us to perform load balancing because we balance the load when I'm running a query, because partition is a part of optimization, performance optimization. We are setting this mode as a non-strict. We are saying parallel execution will be true, and whenever, even when we practice Hive query and we open this Hive cell, so in Hive cell we submit this line one by one, right, to enable our dynamic partition properties, their mode, and the parallel. What few more properties we had for bucketing, but I'm not using any bucketing in this. That's why I'm not using for bucketing. Otherwise, I will write set and one more value, Hive dot bucket. This is equal to true. So bucketing will be also enabled. Now, after this three line, use ETL data schema. So this is using ETL data schema. Now, I don't know what is ETL data schema. Let's go and check from user TMP directory. Everything is there at user TMP directory. cd user tmp, then cat and parameters. So it is ETL data schema, that's FIU. It will create inside FIU, and I'll go to Hive cell and I will check if this table is present in any default database. I will delete it. Otherwise, it will start appending with the existing data. So databases. FIU, there is nothing inside FIU, but inside default, I will check. So tables, this is also okay. We don't have any table as dim customer OTL. I'll minimize this, or maybe I can exit from here. Let it be, because we need Hive cell. After selecting this database, which is FIU, insert from line number 20, insert override table. This is the query when we want to get the data from one table to another table. So insert is known as the intra-Hive communication. Intra-Hive communication means table to table within Hive. So table 1, this is my dim customer OTL. Dim customer, I'll use a short form, okay? Dim customer OTL. This is present in default database, and from there I'm using this FIU. This is in default database. This will store data to second table, and this table name will be customer dim main. This table name will be customer dimension main, and this is inside FIU database. So from this to this, communication will happen, and that is happening through insert command, which we are calling as a intra Hive communication, because within system we are doing inter, we are not doing, right? And if you say enter, then it's going outside the Hive. Partition update dates, we're partitioning, and this is the syntax. Whenever you use any partition, that partition column should be the first column for to define. And then this query, select customer ID, customer alt ID, customer name, gender. All this result is coming from RDBMS, my dim customer table. I use cast. This casting will change this load date to timestamp. Okay, this is a casting, type casting. So when we say cast, load date will change in timestamp. Current date will be picked up from my system, which is 26 July today. Null is what? Closing date. We will see all this column value when we create this table. We have not yet created this table. We will create this table inside FIU. Okay, so this part is we have not yet performed this stage. We'll do after this. So how many number of column is there? This is column number 1, column number 2, column number 3, column number 4, 5, 6, 7, 8. 8 columns are there. Now in RDBMS, if you go, there are only few columns, not 8 columns, and we will check that. My SQL so databases, which database we are targeting? PRWA. And table name, I'll directly write the table name. Select a star from table name, and that table name is dim customer. How many columns we have here? Customer ID, customer alt ID, customer name. 5 columns are there. And all these 5 columns is here also. Only we are converting this load date to timestamp using casting operation. But this 3 columns are coming from where? These are 3 new columns which we are storing inside customer dimension main. Okay, so this we are giving by ourselves. It's not a part of the highlighted area from line number 27 to 30. This is not coming from RDBMS. This we are writing in the query. Current date is a function which will read your system date. This is a Hive function. Null, in null, sixth column value of customer dimension is null. So this way, if we talk, it is confusing. I'll do one thing. I'll first create this customer dimension table. Okay, I'll open. So my Hive cell is already open, and the structure I will get it from here. So prerequisite I have set in one file, and that file is user tmp. That file is prior setup. So this is your file. Whenever you confuse, you can open this file. Here I have written this step, what you will have to do one by one. So prior step dot text. First, create a scoop job. A scoop job we will create when we run daily jobs. Currently, I need all data as a full snapshot to my HDFS, right? So I'll skip this step number 1 first. I'll go to step number 2. That's also skipped because step number 2 is based on step number 1. I'll directly start from step number 3, where we are creating this table. I'll set a number for this. Set this we are creating. So this is a DDL for Hive table, and what we are doing in this DDL, create table, customer dim main, and this is the same table. We will check from here. This is the same table, this table and this table. Okay, customer ID is your first column, customer alt ID is your second column. This is taking data as it is from RDBMS. Customer name is third column, gender is fourth column, load date timestamp is fifth column, so fourth, fifth column. Then effective from date and effective to date, this we are giving. So effective from date means the day when somebody has started the transaction, or we are talking about financial business. So when that person has started an account in bank, that is going to store in this effective from date, opening date, and effective to date means when this account is getting closed. If account is closed, we will write the date. If account is not closed, and that is why I have given null here. So in current date, which is column number 6th, this is column number 6th. This is taking my system date null, column number 7. So this null is for effective to date. When account is closed, then only this will change the date. Otherwise, this will be null because it will tell me account is active. And for active and inactive status, we have created one flag, active flag. If account is active, we will call Y. If account is inactive, we will call N. Account inactive and active means the same thing. Today you have started one account. So I'll take my example. I have my customer ID as cust ID 201795. I'll have my name. I will have city, state if you want to write, balance, opening date. This will have some open date. Say I started this 2018, 10th October. And if it is having timestamp, we'll write that time also. And obviously, writing time is more giving us good information. So we'll keep this as a timestamp and we'll write this account is started at this time as an open at this time. Open date and close date. Close date is currently null. This is one row. Now I applied to a bank online that I want to change my city because I have relocated from Pune to Bangalore. Customer ID. Customer ID will not change. Name will not change. Only one thing will change, that city. City will be Bangalore. State will be, state is also changing, is KA. Balance, whatever balance is there, 8,500. Open date, open date. Now this, in this open date, we will have open date for Bangalore city. When I have applied to branch of Bangalore of SBI, let's say, so they will write that date because this is a history now. They will write that date. Suppose this date is 2019 and 11th November, 8:13 hour IST. Close date is null, but this close date will have some value now, and we want to maintain this data. If I'm keeping this both the result in one table, let's say that table name is customer detail. If we are having this both the row in single table, then this is a duplicate, right? If this is a duplicate, we will confuse that which one is active result. How do I know this is history or this is history? We cannot check one by one. That is the reason we are giving this flag, active flag. Active flag will tell me, so this table I'm creating in Hive, which is my final warehouse. Active flag, I will set this as N, which this is no more active now, and this I will set as Y. So it's a warehousing concept. If you are keeping multiple data from same customer ID, then we should know which one is active and which one is inactive. And suppose after 3 years again I change my city, located somewhere else, again I apply to a bank, then they will make this also as a non-active. And then they'll make one more entry with the same customer ID. So one customer ID has 3 rows now, but only one is active and rest 2 are inactive. Now why I'm storing this data in my Hive final table? Because history is important for data analysis purpose, to check any activity of a user. What was last year balance, last to last year balance. If we delete history, then we don't know the person. It's like the person is new for our bank. Okay, so just to maintain this, we are giving one active flag. Active flag, why in this, and two things will be there. It first we are saying why. So currently all the account is active, all the account is active. Then partition by update date, this is the result for that. Update date will have date along with it, time also. That's the reason I'm giving this as a timestamp. Transactional is equal to true. What is this? This line is a very important line. And obviously line number 43 also. In Hive, there we know multiple format. RC, ORC, Parquet, Avro, text, right? Sequence. So these are all Hive storage, Hive file format. And ORC we are using because ORC is the only format which allows us for insertion and updation. insertion is applied everywhere. Updation and delete. So if you want to do update on table and delete some data from table, this is the only type, optimized row column, which will allow us for this two activity, update and delete. Insert is by default available for all the types of data, including comparisons. Okay, so we know now reason why ORC, why this transactional true we are giving as a table properties. After this, in this table, this information, this script is doing this thing only. Then rest, we said 4, 5, and 6 stage, we did already. We moved all the file. So this is the first step. Even when you do practical, first perform 4, 5, 6 step. Take all the file from local file system Windows to your cloud era. Keep it this directory, user tmp directory, because my script is running from user tmp. If you change your directory, then your script, you have to open a script and change all the location also. So don't make it complex, just copy it this directory. Give a permission 777, which is a full permission, read, write, and execute. And then we are running this. ETL job cust dim OTL and custom. Well, I'll exit from this. Whenever we stuck anywhere, we'll open this file. This is like a guide for us, prior setup.txt, or documents for us. Now table no, we know, and yeah, one last thing, table is not yet created. So I will create a table. And how to create a table, I will read prior setup from here. Prior setup, copy this line, excluding parenthesis, excluding semicolon, copy this and paste it hype cell. Our hype cell is already open, I think somewhere. This is a hype cell. I'll select my database, which is a FIU. So tables, no table is there. Right click, paste, and we'll verify all looks good, semicolon, and enter. So tables, so we have got customer dim main table available in this FIU database. So prerequisite wise, we are good now. We have checked our both the script from this directory. One second, from this directory. This script we have checked so far, and this script. And when we check this, we know ETL OTL.sh, this is triggering, this is taking this script, because here we have three stages. First stage is scoop, using scoop RDBMS to HDFS, RDBMS to HDFS, and in HDFS, then they're pointing to one table which is dim customer. That's my second stage, by the way, dim customer OTL. And in third stage, it is moving dim customer OTL data to dim customer main or customer daemon, whatever name I have given. So dim customer OTL to customer dim main, customer dimension, dim stand for dimension underscore main. In this table it is going. This script is calling this script. Okay, it's a HQL script. So it's time to run this now after validating. And IP address we have already given. We'll check this ETL data last. I've given already, but if we start and it fails in between, then again we need to resubmit this. So check the IP address, which is important point. This is not yet checked. Look, we did not save this. So this was 41.1. Now we'll save it. And that's it. sh space, you will have to run this etl job dim underscore otl. Permission is not yet granted. One more thing, permission is not yet granted. Okay, permission means we have not granted permission from MySQL for this IP. So here we will run one command, grant all privileges on star dot star username dot all the table name to root, which is username of MySQL, IP address of vmnet1 identified by password of MySQL with grant option, with grant option. Yeah, run this query and now we are good. So you can call using sh. This is one option because of shell script. I can call using bash also, using bash. I can call using ksh. K stand for cone cell. If it is having ksh extension, okay, I'll use sh. Ksh is another format of shell Unix scripting. Then, or I can call using dot slash. Many ways are there. I'll use simple sh space this. And we will read the log file. Once this is all done, we will check our data, we'll verify. This will take 3 to 4 minutes. But meanwhile, we will read all the log file. So currently it is connecting to your dim customer. It has written the jar file. Your job is going to resource manager with port number 8032. Then they started running a query, select min max from the table name. Number of split we have given 1. So whatever data is there, it will only perform one task because number of M is 1. One task means it will go to one CPU. Job, this is the job ID and this is the URL. Using this URL, you can track it. How many percentage mapper done, how many percentage reducer done. Your job is working on application master now, which we can track using 8088. This is the port number of application master, 8088. 8032 for resource manager, 8088 for application master. Then there is 19, I guess 888 or 088 for node manager. Yeah. Map 0%, reduce 0%. Mapper once 100% done, then my job is completed because we don't have any reducer in this scoop part. We have only mapper. Hundred percent done. Job is completed, and we get acknowledgement also. Job completed. Number of counters from MapReduce. We have seen many counters, and this is a time total taken by our system. 7. CPU 7.41 seconds done, and your scoop job is completed total, including query, CPU time, everything is 2 minute 40 second, right? 160 second is 2 minute 40 second. This is taken by scoop job. So we'll write as an observation that from scoop to HDFS it has taken 160. Now it is doing intra-hive communication, one table to another table, dim customer OTL to customer dimension main. Again, they submitted one job. Number of mapper is 1. Reducer is not 1 or 2, it is 0 because we are not doing any aggregation. We are only sending data or transacting data from one table to another table. Once mapper 100% is done, our job is done in 74 seconds. So Hive total time is 74 seconds. This is the total number of partitions we have based on date. In real time, real time Hive table, we use partition for date only. So when we are running a query, we use that condition, date condition. So our automatically data is fast, query is fast, because in a single month we have 30 days, right? So every day data we are partitioning as a date wise. So when question comes which partition, after this I will tell you the synopsis of this project. So we will tell date is our partition column. Now why date is partition column? Because based on the date we are running a query. So we are giving this as a condition. So automatically data is filtered. Then total time by this process is 234 seconds, roughly 4 minute some second. Okay, it's not 4 minute also, I guess 3 minutes some second, because 234 second, 4 minute is 240 seconds. So 3 minute and 56 second, 54 second. Now, uh, time for validation. So we'll go to Hive cell, and here we will first check our default database. So tables and dim customer OTL is there. This dim customer OTL will have exact data as this. This is like a full snapshot. So complete information of this is going to dim customer OTL. I'll run a query, select the star from table name. Dim customer underscore OTL. You can see number of columns 1, 2, 3, 3, 4, 5. And what is the column name? We can use disk function, disk or describe function, dim customer underscore OTL. And this is the column name, same number of columns and same name in fact as this. But interesting part will be FIU database. So FIU database and suit tables, customer domain we had created. Now we will run a query, customer dimension main. It is having data. So now we'll match. This is as it is till column 1, 2, 3, 4, 5. Till fifth column, this is as it is 1, 2, 3, 4, 5. In fifth column, I have casted, right? In this customer dimension main, when we open our .hql file, so I have written cast function, and in cast function I said load date as timestamp. So they are taking the current date here, and this is based on the timestamp. So 201911, and this is for result of 8. 201917, you can check this. Then this is for Richard Trubin, and here your data is splitted 8, 9, 10, 7, 6, 12, 11. So based on what they're doing, they're giving us 8, 9, 10. We'll check this order, how this order is coming. So all the data is there, and this column is new column. This is my current date column according to system. This is the open close date column. Currently account is all active, that's why all null null null. In query we have given null. and all the account is active. That's why everywhere it is y. And this is the loaded date, updated date. Using this only, we are using partitions. So this is the partition column. This is the partition column. If you want to check that partition column, you can run uh, so create table and table name. So it will tell us which column is partition column. After this result, this is a full snapshot. Now I said this person is changing the account, and we will do the same. We'll take the same case. I'll tell you for update first, okay? Or maybe I can tell you for insert also. So update we will see first, then we can check second one, insert. Update, and update is strictly saying one thing, that I must need date, because without date we can't update it. Whenever you work with Hive and we update any row from a table, that row must have date column if you're using a scoop extraction. Otherwise it will not work. Because why we have this limitation? For update query in a scope, we run hyphen incremental with last modified option. This is our argument value. This is argument value, last modified, right? And then we give a column name. I'm writing here itself, check column. You write a column name, which is a date column, let's say open, or whatever date column is there. Okay, open date or update date. After check column, you write the last value. So last value of this column, if I'm updating this person XYZ city, so I will give this as my date, because this is changing only here. Okay, so we'll give this date here in this place, then automatically it will work. So let's go and see how update will work. First we'll update one result from this, then that update result will extract from here to Hive, and we want to keep that data in main table. Select update, and let's update any customer name. Customer alt ID also I can update. Let's update customer alt ID because name is not logical. So update table name dim customer, then set customer alt ID is equal to, which value will change? Will change for Rio, second last. His value is IMI 012 or 011. So we'll change this to 0110, let's say. Condition where customer name or where customer ID. For BigQuery, customer name will trouble you because if multiple customer has same name, then it will update for all. That's why we use customer ID. So customer ID is equal to 11. This job will be done by RDBMS team or DBA team. They will do this and they will alert you or notify you that this is our updated result. We want to get this data also in HDFS repository. Run this query and recheck using select star from table name, and Rio customer alt ID has been updated with our latest result. Now we want this result also in Hive, that too in the same table. We want this result also in Hive and in the same table, which is customer dimension main table, right? Customer dimension main table. But previous record should be inactive, or their flag status should be N, and this flag status from N to Y, because this is the latest result. This is inactive, N means inactive, and Y means active. Okay, but are we directly taking data from this scoop to customer dimension main table? That's a question, and that is only a stage where we perform data modeling, such as CDC, changing data capture, changing data capture. And second one is SCD type 2, which is slowly changing dimension type 2. Slowly changing dimension type 2. As I said, CDC is managing. Read the full format. You'll understand 40-50%. Changing data capture. So whatever data is changing from source, we will capture that result in this stage. And slowly changing dimension means this SCD type 2 output will point to Hive table. So before pushing this result to Hive final table, which is this, I need to perform CDC and SCD type 2. Okay, so today, if you have checked it already, that's good. Otherwise, please read this, go through, take some time and read CDC and SCD type 2, what they do, theoretically at least. Okay, what internal story we have in this CDC and SCD type 2. And I will share you I'll share you the complete script today, right after this class. And please open this file from your system and check this. This is a simple Hive query. And today we'll check this. So this is, I feel this is a little bit complex. Complex as in it takes time to understand. That's why if you already have checked this, we can get a little faster. In this script, this is my script number second. In this script, what we are doing, we're running 7 stages. So we're taking data from one table, we are comparing this. So my CDC and SCD type 2 I have written here in this script. All cases of CDC and SCD type 2, how they will deal with the updated result and inserted result. So here we have 7 stages. Don't check this all in one shot, because these are a script. What you can do, you can run this in one by one to cell. So whenever we confuse in a script side, we should open our Hive cell just like this and copy this query and run one by one. So run this query first, then run second query first. So most of the query you'll understand. Only one query which may take time is stage number second, because here I'm doing binary comparison. If you understand, that's okay. If not, I will anyway explain you tomorrow this. I'm doing union all, and last this is loading it to again customer dimension main table. So we'll check this part tomorrow.